Hey guys, it's Miss Baker. Today we're going to go over the lecture on page 222. What do families, oxidation numbers, and charges have in common? Okay, all atoms want to have their valence shells full. This makes them stable. So I want you to think about a tire that is balanced. If a tire is not balanced, it'll get wobbly. I want you to think of these shells the same way. Okay, so the goal of every single atom is to have its valence shell full. And it can achieve this by donating electrons or stealing electrons. Okay, so here is another picture of the periodic table with the valence shells and the valence electrons. Right. So each family has the same charges and oxidation numbers. So let's go back. Okay. All right. So see hydrogen right here. Hydrogen wants to look like helium. For hydrogen to look like helium, it is going to steal an electron. You see, it's only got one electron. It needs to have two electrons to have a full shell. So what it's going to do is it's going to steal an electron. As it steals an electron, it has one extra negative charge. Remember, electrons are negatives, protons are positives. So if it steals an electron, you are going to have two negative electrons and you're going to have one positive proton. So 2 negatives plus 1 positive equals a 1 negative charge. So hydrogen is a -1. Okay? This hydrogen is really a -1. See right here? Okay? So each family has the same charges and oxidation numbers. Charges and oxidation numbers mean the same thing. Okay, so this first column, everything here has a +1. Now, hydrogen can be a +1 or a -1, depending on what it needs to be. Anything in the second column is going to be a +2. We skip all of the transition metals. Anything in the third column is a +3. Anything in the fourth column is a +or -4. Anything in the fifth column is a -3 because it only needs to steal 3 electrons. Anything in the sixth column is a -2. It needs to steal 2 electrons. Anything in the seventh column is a -1. It needs to steal 1 electron. And anything in the last column, its shell is full. It will not steal, it will not donate, and it will not bond anywhere. All atoms of all elements achieve this balance by stealing or donating electrons to look like the nearest noble gases. Stealing electrons creates a negative charge, and donating electrons creates a positive charge. These charges are noted as a superscript on the right side of the element symbol. When electrons are gained or lost, the number of protons and electrons become uneven. This makes the atom charged. An atom that is charged is called an ion. Losing electrons equals a positive charge, and that's called a cation. Gaining electrons equals a negative charge, and that is an anion. Now, the way I remember this is a cation reminds me of cats. If you want an elderly person to live a while, a long time, you want to give them a cat to love, and that will be positive for them. I remember gaining electrons and a negative charge is an anion because I think of onions. When I cut onions, it makes me cry, and that is a negative thing. So I think anion, onion, negative. The oxidation number is the charge or amount of electrons that are gained or lost to become stable. Again, this is called an ion. Anything in this first column is a +1. It is donating one electron, and it is a +1. The easy way to remember this is extra electrons is positive. They want to give them away. A negative is missing electrons it wants to steal. So anything in this first column is a +1. Anything in the second column is a +2. Anything in the third column is a +3. Fourth column is a plus or -4. The fifth column is a -3. Sixth column is a -2. Seventh column is a -1. Eighth column is 0. Now here's how I remember this. I always put my finger on carbon. Carbon is a plus or a -4. It is equally easy to gain 4 electrons as lose 4 electrons. What I have to remember is if I go to the left, I am going to go 3, 2, 1, and those are all going to be positive. So if I look at boron, I see carbon is a 4, so I'm going backwards 1, so that's a 3. So boron is a +3. But if I'm looking at nitrogen, I put my finger on carbon again as 4. I'm moving away from carbon, so we're going backwards again. So nitrogen is a 3, and because I'm going to the right, it is a negative. So anything from carbon going to the right is negative, and you're going to go 3, 2, 1. Anything from carbon going to the left is positive. Again, you're going backwards. 3, 2, 1. Now, ions act as magnets. So if you have 2 atoms, one of them, like sodium, which is a positive, and chlorine, which is a negative, they are going to charge. What's going to happen is the sodium is going to give its electron to chlorine. Sodium is going to become a +1 because it's got more protons than it has electrons. Chlorine is going to have more electrons than it does protons, so it's going to become a negative charge. So sodium is positive, chlorine is negative. They are unlike charges, so they're going to attract. Versus if you have 2 things that are positives, they're going to repel each other. Okay, so like charges repel, unlike charges attract, just like magnets. The fewer electrons an atom gains or loses, the more reactive it is. So the most reactive metal is francium. That's right here. Okay, so these are the most, francium is the most reactive. These right here are the second most reactive metals. And as you move outwards in these circles, it becomes less reactive. Now, the most reactive nonmetal is fluorine. Okay. And as you move away from fluorine, it becomes less reactive, simply because it is much, much, much closer to this noble gas for it to react. It's going to want to react very, very quickly. Okay, and that is page 222.